You need to think really hard today, so there's no sidetracking, no nothing. These ones are where it makes it a bit harder. So we're going to pay attention, and your assignment, that hand-in assignment, is posted in Google Classroom, right? You can print it if you'd like to do it. It talks about switches, on and off switches. If you have no idea what I'm doing, what I'm talking about right now, that means you haven't either opened up the assignment or you're doing the wrong one. So it has on-off switches on the very front cover. That is due on Monday. And you have to be able to do today's to finish it, right? This is on it. So this one here says the term with y5 in 5 minus 2y to the 8th. So we talked about this. One more than the exponent is the total number of terms. So there are 9, right? You can go t1, 2, 3, 4, 5, 6, 7, 8, 9 if you wanted to find all the different terms. That would take a long way to find out which one has y5. So we're hoping to not have to use that method where you have to find every term until you get one with a y5, right? So what can we do if we don't know? Well, we do know this. We know that this will always be our x. We know that we have to have a plus sign in between because the formula says it has to be an x plus y to the n. We know that this is our y. We know that this is our n. The only thing we don't know is k. So we could just put a k in for k, or we could put a box in for k, but that's the only one we don't know. So if we're stuck and we don't know one thing, we're going to fill everything else in and see if somehow we can maybe figure out what k would be, given this piece of information where they said, oh, the term has to have a y5. Hopefully that can help us out. So we're going to go tk plus 1 equals, and if you didn't want to, you could put a box in for k. Then we have 8ck x, which is 5, to the 8 minus k, and then negative 2y to the k. Now, did they give me enough information to figure out what k has to be? Yeah? What does k have to be? 5. And the reason why k has to be 5 is I need it to be y5. This is the only term with a y. And I need this to become y5. It's y to the 1. They're multiplied. So this has to be a 5. Right? Which means this has to be a 5, and a 5. So I'm going to rewrite it instead of doing this. So I'm going to get t5 plus 1 equals 8c5. That is not 8. That's 5. 5 to the 3, and then negative 2y to the 5. The other thing about these exponents is these exponents up here should add up to n, to 8, right? Because you're doing subtraction. And 8c5 is what? 56. So we get term 6 equals 56 times 125 times negative 2y5. Is it times negative 2y5? What do we have to remember to do?
X minus 2, 5, and now y5.
Yeah, we have to remember to do that distribution. So it's actually minus 2 to the 5, which is negative 32, y5. We have to remember to distribute, exactly. And I told you this before, but I'm going to ask it again. If you forget to distribute, do you think the answer will be on your test and on the diploma? Yep, and it's picked often. Okay? It's wrong. And then we have to put our coefficients together. So 56 times 125 times negative 32, and we get term 6 is negative 245,000 y5. Now it asks me for the term width. Well, this is the term, so this is what I would box. That's the term. What if it asked me for the term number? What would your answer be? Yes.
T6.
T6. So it would just be a 6 in the numeric response box, right? If it asks for the term number. If it asks for the term, it's your answer. That is the term. Did I put something in wrong? 56 times 125 times negative 32. Haha! I put it in 35. That'll be a bummer. That's not going to work. Wow, now I added a 2 somewhere in there. I just put 35 again. Woo! This is a rough go. 224,000. Yeah. Then we're flipping over. So we're going to need the big thinking caps. So at the top of our notes, we have this, the constant term, what is a constant term? What is a constant term? Anyone remember? Yeah.
Then like the coefficient, like it would be like 2 in that case.
That's coefficient, constant. You're in the right path. If I give you this, f of x equals 3x squared plus 2x plus 7. What do you think is the constant? The 7. People can tell me what the constant is by an example, but they can't tell me what the constant is by words. The constant is the number without a variable. And if you do give it a variable, what is its variable? X to the what? It's x to the 0. Because what's anything to the power of 0? 1. Anything to the power of 0 is 1. So what's going to trick you up in this lesson is not the grade 12 stuff. It's going to be your grade 10 exponent laws. Okay? So we're bringing back our grade 10 exponent laws. We'll go through them, obviously. I won't just wing it. But it is going to use your grade 10 exponent laws. If you can't use those, you're going to be in trouble. So the first thing is this x squared on the bottom confuses people. Okay? We also know we're looking for the constant term, so we're looking for the term without a variable, or if we give it a variable, it's an x to the 0 variable, right? Because x to the 0 is 1, it cancels it out. 20-year-old, I'd say that's about 16 to 24-year-old boy, I'm guessing. It's a truck with a muffler, that's what that is. I can peg it. I'm from Saskatchewan. 97% of guys between the age of 16 and 24 drive a truck with a muffler. And some, like, back. All right, so we are going to go and we're going to write this as 2x plus negative, right? Oh, exponent laws in grade 10. Sometimes this is the downhill spiral of grade 10 mathematics. This is the exponent line unit. It's not that bad. It's just hard for people to understand when your brain is in grade 10. But grade 12, you guys are fine, I promise. So the negative 1 sits here, right? Like the negative 1 doesn't have to move. The negative 1, the negative and 1 are attached. The x squared on the bottom is my problem. Do you remember that if we want to move something from a denominator to a numerator, what happens to the exponent? You flip the sign. Yes. So if I am moving a positive x squared from the denominator up, it's going to become x to the negative 2. If it was x to the negative 2, and I moved it to the numerator, it would be x to the positive 2. It just changes the sign of it. That's all that you get taught in grade 10. And for the most part, what in grade 10 lessons make you do is take negative exponents and make them positive because they're easier to deal with. Like when you want to multiply 2 and they're both the same, they're both positive, it's easier to multiply 2 bases and exponents. So we're going to bring this up here. We're just moving the x squared. So when we move it up to the numerator, it becomes x to the negative 2. And then 15. And it's a lot easier to deal with. So then this is my x, this is now my y, this is my n. I still don't know my k. We agree? But I can make my k show up algebraically. So this is what we're going to do. We know that we need a variable to go away completely. We need the x's to get out of our lives because if there's no x's in the term, then it's a constant, correct? Which we also talked about, the constant is also just the variable x to the 0. That's also the constant, would have that on it. So let's fill in our formula. So we have t, k plus 1, I still don't know k. That's what I'm going to try and find. N is 15, c, k. And then x is 2x to the 15 minus k. All right, so we have negative 1 x to the negative 2 to the k. Now, what do I need to do? I need that when these are all being multiplied, right? Is this not just being multiplied? True? Okay, let's go back to grade 10. If I gave you x to the 2 times x to the 3, what was your answer? X to the... There's going to be a 6-5 conundrum happening here. So when we don't know what we do, we go to this one, which is easier. X squared with a 3 out. What's this one? X to the 6. So what is this one? 5. Because what do you do when you have two bases and two exponents? You add them. Right? You add them. Okay, so let's talk about this. This one, this 15ck is being multiplied by 2 to the x is being multiplied by this, correct? So technically I'm multiplying x's here, am I not? This x to some sort of 15 minus k, this x to some sort of k, they're being multiplied. So I can pull just the x's out of this term. So let's pull the x's out, not the 2, not the 15k, not the negative 1. I'm trying to find k, so I'm just going to pull the x's out. So I'm going to pull out x to the 15 minus k. I'm just pulling the x's out, and then I'm going to pull this one out times x to the negative 2 to the k. Oh, I'll stay. Whatever, if you really want to. Do you see I just pulled the x's out? All I did was pull the x's out. Did everyone see exactly what I'm doing? Because this is important. Okay? Now, what do I need that to equal in the end to find the constant? X to the what? X to the 0. So I need that to equal x to the 0 to find the constant, do I not? Okay, well let's just start solving to figure out what that k needs to be in order for that to happen. So here I'm going to have x to the 15 minus k, and this one I have to remember to distribute. If there was like a squared in here, I'd have to put it to the 15 and to the k. Remember, you have to distribute it through. So it's x to the 15 minus k, and then x to the negative 2k equal x to the 0. What do I do? Grade 10. 2 bases, 2 exponents. What do I do with those exponents? Add them. Add them, right? So I'm going to get x to the 15 minus k minus 2k equals x to the 0. Is everyone following me so far? I wish I could go to the grade 10s and have them believe me that grade 10 math is so important because almost all of 30 finishes as grade 10 math. Or grade 11 math, but more so even grade 10 and grade 11. Sometimes both. I wish I could sell that to them because sometimes they don't try as hard as they need to. Okay? Now, I can combine these. I get x to the 15 minus 3k equals x to the 0. Now, what can we say about this? If this is x to a certain exponent and it equals x to another certain exponent, what can you say about those exponents if this is a true statement? They're equal, right? So I have 15 minus 3k equals 0. 15 equals 3k. And what does k equal? 5. And then I can go in and just solve my constant. You could also guess and check k values. So if this is 15ck, this would have to be 15 all the way to 0. Those are my only options. So you could guess and check 0 and see if it gets to cancels 1, see if it cancels 2, see if it cancels 3, see if it cancels. Like you could put them in for k and see if the x's cancel that way as well. So now I'm going to get t5 plus 1 equals 15c5. 2x to the 15 minus 5, negative 1x to the negative 2 to the 5. So I get T6, term 6 equals 3003. And then I can't forget to distribute the 2, or the 10 to the 2 and the x. So 2 to the 10 is 1024 x to the 10. And then here I get negative 1, because the 5 has to, don't forget to distribute the 5 to the negative 1. I know in this case you would have lucked out had you forgot because it's to an odd exponent, right? But if it's to an even, it would turn it to a positive 1. And then x to the negative 10. What happens when you have an x to the positive 10 and an x to the negative 10 being multiplied? They cancel because it's 10 plus negative 10. So these will go away. And my answer is 3,075,072. We still have another example to go, but in the meantime, I'm going to have you start working on your homework. So I'm giving you a few minutes to work on your homework as you go along. Yeah.
What happened to the negative sign?
It's been there the whole time, Alex. I have no idea what you're talking about. Yeah, I was wrong. I forgot it. Good catch. People would have just.
Two in a row. Two.
You know what? It's Friday. Do we have to go back to when you were on the board?
No,
There was more than two in a row. I'm saying, you know what I'm saying? You know what I'm saying?
No, my bad.
There was an eraser conundrum. There was a few things. All right. We won't go there, though. Nope. Okay. Good job. So, in the homework, your homework is going to end up being this. So this is all going to have to go into a homework spot. So please don't do it on the page that you're on, because you're going to have to hand this to me when you hand in the homework. So go to your homework spot. What your homework will be is 18B, 19, and 20. But right now, what we're going to do first is just, I'm going to let you work on 19A and B, and I'm going to write them on the board because your textbook should be on Monday. So 19A is determine, I don't even know what just happened. Determine. And if you don't get the right answer, put the right answer on the board. If you don't get the right answers or you're stuck, put your hand up, right? This is your homework. You're trying it out. If you get stuck, you ask. And I'm not giving you the rest of the class. I'm just giving you some time because we still have another example. So determine the constant term, and we're going to do the ones that aren't just constants. So the part that's in the red is the actual answer. So you'll know you're right if you get those red answers. If you don't get them, put your hand up. Ask a question. Make sure those are copied down. We're going to look at one that isn't, we're going to look at one that isn't a constant. So we're not looking for x to the 0. We're going to do 18b, which actually looks for a term containing x to the 11, which is different. Remember, you should be trying this on your own first, because if you're just copying it down, good luck. So 18b is the one we're going to try now. 18b has determined the term containing x to the 11. So constant term I think is harder than the one that's x to the 11, because if I say constant term, you have to know it's x to the 0. Right? If it says constant term. Determine the term containing x to the 11 in the expansion x squared minus 1 over x to the 10. So we still set this one up exactly the same. The only difference here is that we're not going to set this equal to x to the 0, which is a constant term. We're going to set it equal to x to the 11. That's the only difference. And we only pull the x's out. So we start it with labeling what we have. We have x. Our y is this. So our y is actually, this to the 1, is equal to negative 1 x to the negative 1. And this is n. So we do term t, k plus 1, we don't know what k is, equals n, which is 10, ck, none of this changes. x is x squared to the 10 minus k. That's not a k. 10 minus k. And then y, which is negative 1, x to the negative 1 to the k. And we only take the x's out. Do you see how that 1 has a negative 1 in front of it? I don't care. When I take this off to the side to find out what k is, I literally just take the variable with the exponent, the other variable with the exponent. If this happened to have a million in front of it, right? That and a million in front of it, I wouldn't take that. I'd still only take the x squared. Okay? So I'm literally just taking the x's and their exponents. So I am not going to take this negative 1 over there. It's just going to be the x squared to the 10 minus k and the x to the negative 1 to the k. That's the only thing I'm taking off to the side, just the x's. So I'm going to do x squared to the 10 minus k times the other x. I'm not taking the negative 1 because I don't take any coefficients. X to the negative 1 to the k. And when I wanted the constant, I set it equal to x to the 0. But I don't want the constant this time. I want the term containing x to the 11. Yeah. And when do you know to do this? When you get one with a variable like y and the other one's a fraction. That's when you'll always do this. When you have one normal variable and one with a fraction that you have to pop up to the negative exponent. Okay? So I have to remember to distribute. So I get x to the 20 minus 2k times x to the negative 1k equals x to the 11. Back to grade 10 math. If I have two bases that are the same, I add the exponents. So I am going to get x to the 20 minus 2k minus 1k equals x to the 11. And I can collect like terms, if we're talking grade 10 again, collect like terms. So we get x to the 20 minus 3k equals x to the 11. If they're both the same base, so something easier than this, because I think I'll lose people here. If I had x to the smiley face equals x to the 11, what would you tell me? Smiley face equals 11. That's the only way that these actually could be true, right? If this is x to the smiley face equals x to the 11, well, then smiley face can only be 11 if that's a true statement. Right? Does that make sense? So, instead of doing something more simple like that, we have this. I have x to the 20 minus 3k, pretend that's a smiley face, right? Equals x to the 11. So smiley face equals 11, right? Smiley face just happens to be 20 minus 3k. Does that make more sense why those are set equal to each other? Like if we treat this like it's a smiley face would be 11, right? Equal to 11. So instead of a smiley face, I have 20 minus 3k. So 20 minus 3k will equal 11. Then I have to solve, so I subtract my 20. And I get negative 3k equals negative 9, so k equals 3. And then I go back and solve. T3 plus 1. They could also just ask you for the term number and I'd be done, right? It would be term 4. If they asked for the term number, I wouldn't even have to solve it out. But I would to double check myself. So I'm going to get 10c3 x squared to the 10 minus 3 negative 1 x to the negative 1 to the 3. And then I have to remember to do my distribution. So T4 equals 120 times x to the 14. And then you have to remember to distribute to the negative 1. Luckily, if you didn't remember, it would still have worked because negative 1 cubed is negative 1. Negative 1 x to the negative 3. And so I get T4 equals negative 120. And what happens when I multiply x to the 14 and x to the negative 3? Two bases, two exponents. What do I do with them if I have the same base? You add them. What's 14 minus 3? 11. We have the right term. Then I'm going to have you flip back to the last example in your notes. Okay? So this is the only other type. So there are like three types of things they could give you. They could give you, ask you to expand a whole binomial, which we did. Term 1, 2, 3, 4, 5, and then write it out, correct? Or they could ask you just for term 6, or they could ask you just for term 4, or they could ask you for a middle term. Or they could ask you for a term that contains y5. Or they can give you these weird ones where they give you like x and then 1 over x, or y and then 1 over y squared, or something like that. And they ask you for the constant, which is x to the 0, or they ask you for the term with x to the 11, or y to the 5. The last thing they can do is they can actually give us the term. Up till now, we've always just found the term or determined the term number. That's it. Every question, we have determined the term number, like 6, or we've given the term, what actually it is, what that term is equal to. What they can do is they can actually give us what the term is equal to. Do you see this? We've never been given what the term is equal to. They can give us what the term is equal to, and then ask us for something from the binomial. So here it says one term. They didn't give us the term in the expansion. This one's nicer because it says the 11th term, so I know k is 10. Right? That one's nicer. We're going to do the harder one. One term in the expansion of x plus a to the 10 is that. That's the answer. They want to know what a is in the binomial. So now they're actually asking for something in the binomial instead of like giving you the binomial and asking for the term. It's the last type of thing they could do. So this one here is x. This one here is y. This one here is n. And k we have to find. So what am I going to do? I'm going to fill everything in except k's are going to stay k's, right? So I get tk plus 1. If you want to, you can put boxes in for k2 instead of the letter k, but I'm going to put k's. And then we do 10 ck, x is x to the 10 minus k, and y is actually a to the k. Now normally, when we solve this, we get the term, correct? Is that not true? Like when we solve that out, we get the term. So can we not just take this and set it equal to the term? So we can take what we found here and set it equal to the term. So instead of putting this, we're actually going to put what the term is. tk plus 1 is this. This is tk plus 1. So we're going to get 3,281,250 x to the 4 has to equal this. Do we know what k has to be? Do we have any idea what k should be in order to get a term that has an x to the 4 in it? Yeah. 6. Why? Because when Ty put 6 into here, 10 minus 6 is x to the 4, right? And when we put 6 in for one k, it goes in for all k. So if you can find k in one spot, you're golden, because it's going to be 6 in every spot. So 6 here, right? So we're going to get 10c6 x to the 4, a to the 6. Then we can divide an x to the 4 off both sides. And it goes completely away. So then we're left with 3,281,250 equals whatever 10c6 is. 210? Thank you. 210, a to the 6. And now we're just solving. So what are we going to have to do? How do we just solve this? Next step. We're going to do what? How do we get rid of a multiplication of 210? Divided by 210. I hope you all know that. You're in quiet zone. I think it's 15,000. Yeah. So we have A6 equals 15,625. Caveat. Grade 10 and 11, this is talked about. If I gave you this, if I gave you x squared equal to 121, how would you solve it? Square root. When you have to remember to do every time you take a square root. What goes in front of the square root sign? I know it's been drilled in. I know the teachers teach it. Positive or negative. So we're getting x equals plus or minus 11, right? If this was like a caveat, a side note of what you did in 10 and 11, correct? When you take an odd root, you don't need the plus or minus because you can take a cube root of a negative number and then the answer is negative. A cube root, or sorry, 3 root, of a positive number is positive. So you get whatever the heck they are. So when they're odd roots, you get either positive, it's under positive, or negative, it's under negative. If it's an even root, so square root, now a 6th root, we'll always get plus or minus in front of it because it can be both. So when I take the 6th root of this, I need to remember plus or minus. When I take the 6th root of this, I need to remember plus or minus. How do you take the 6th root? Well, you go 6. You press the number 6. You press math. And then number 5, because you're putting it in for that x. So it's 6, math, number 5. I pull it up, but my calculator will take longer than you guys getting dismissed. So, and you get 5. So A equals plus or minus 5. And you need the plus or minus sign for this one, because if I plug a 5 in here, and I raise it to the power of 6, or a negative 5 to a 6, it's still going to give me a positive number. So both of them are the answers. So a reminder of what your homework was. It was page 543, I believe. Number 18b, we already did it. That was the x to the 11. 19, a and b are the two I put on already, right? 20 is the only one we haven't done, and it's just like these ones. Okay? That one you'll get I think it's like the answer's 3y or something. You get a y in it.